Okay, hello everyone. Okay, this is the mechanics of material, and this video, I'm going to show you what is called centroid. Okay, and because when we and in last one video we say when we want to try to do the simplification of distributed load or loading system. Okay, the position of your distribute the after the simplification, your resulting force is acting at acting on your position of the centroid under the load distribution curve. Okay, so we need to use another series of video to talk about what is the centroid. Okay, because this will also use a lot in this semester. Okay, what is centroid? Okay, in the last video, I say it's very similar to what you have learned called center of mass. Okay, so let's start with center of mass. Okay, and before that, we have to to tell you actually in physical system we have a discrete system and continuous system. And discrete system means in a system each object is separate, okay, and there's not nothing between this object. But in material, in the real material, in the object in material, okay, that's called continuous system. Okay, um in continuous system, every tiny object connect to each other. Okay, and the coordinate of each element is any value in the region. And for a discrete system, okay, in discrete system, the position of each object is only certain value. Okay, but in continuous system, the position or coordinate of each element is any value. Okay, so it's a discrete system and continuous system in physical system. Okay, of course, in material mechanics, in material or mechanics of material, we are talking about continuous system. But I will start with the discrete system to tell you what is the center of mass is, and transition, and then make a transition to a continuous system, and then go to the centroid. Go to the centroid. Okay, so let's start with the discrete system. Okay, suppose we have discrete system. There are many discrete particle in a system, and each particle has a position vector and is a mass I. Okay, so the center of mass of this discrete system is just the mass 1, your mass 1 times the position vector 1 plus mass 2, the second particle with mass 2 and position vector 2, and the third particle with mass 3 times the position vector 3, and doing the summation and divide it by m1 plus m2 plus m3 mn. Okay, just divide it by total mass, and then you will get the center of mass position vector in the discrete system. Okay, and as we know, the vector can be we can express our vector using the Cartesian vector system. Okay, so the center of mass, the vector of center of mass or position vector of center of mass can be expressed by Cartesian vector x component, y component, and z component, right? So how to calculate x component, y component, z component of the vector of center of mass? Yeah, use a very similar thing. You just each mass times for x component, just each mass times its x coordinate, because the first mass times is the mass 1 times is x coordinate, the mass 2 times is x coordinate, and mass 3 times is x coordinate, and then add this together and divide it by total mass of the system. And for the y component of the center of mass position vector, you just each mass times its y coordinate. Mass 1 times y coordinate, mass 2 times the y coordinate, and divide the total mass of the system. And the z component of the center of mass position vector, you just each mass times its z coordinate, and mass 2 times its z coordinate, and add them together and divide it by total mass. Okay, it's a discrete system. Calculate the center of mass is not that hard, right? Okay, this is a discrete system. Okay, so in discrete, for the formula of a discrete system, we can transform this discrete system formula to the continuous system formula. Okay, so how to do that? Okay, here we just say, okay, for the x component, okay, you can write in mathematically, you can write it in this way. Okay, suppose we have the mass of each particle, okay, it's small, okay, and small and very close to zero. Okay, and the summation of m alpha x alpha, okay, the mass is very small, okay, and so and we change to a symbol to m alpha to delta m alpha, that means a tiny mass, and times its coordination, its x coordinate, and then delta m equal delta m alpha approach to zero, and this summation is just equal to the definition of integration. So this summation will become integration x times dm. Okay, and then we call the total mass system. Okay, just add all mass of the particle together, and then we call it capital M, big M. Okay, so after this transition, we transition a formula in discrete system to a continuous system. Okay, so in continuous system, the coordinate of center of mass in x component, y component, z component will become like this. It will become x delta m integration divided by total mass m. It give you the x coordinate of the center of mass, and y and in your y integration to your delta m, and y integration to respect to delta dm, and divide total mass, you get your coordinate of y. And the z doing integration with respect to the delta m, and then divided by total mass of the system, you will get the z coordinate of your center of mass. Okay, you see it's very similar. Okay, I think the next slide I have to arrange. I have to list this for the similarity. You will see. Okay, the left hand side is the discrete system. The left hand side is formula for discrete system, and the right hand side is the formula for a continuous system. Actually, they are equivalent. If your m is very small, they are equivalent. Okay, so I should say, make a note here. It's a discrete system. And continuous system. Sorry, I forgot to make a. Okay. Continuous system. Okay. Okay, this is a formula for center of mass for discrete system, continuous system. Okay, we'll start with the continuous system formula. Okay, and okay, and then we're going to introduce. Okay, so what's the center of gravity? Actually, center of gravity, I think the more proper name is center of weight. Okay. Okay, the center of gravity or center of weight is very similar to center of mass. Okay, because in the center of mass, all we care about is mass, right? All we care about is mass here. All we care about is mass. In center of mass, all we care about is mass. Here is all mass. All we care is mass. But center of gravity or center of weight, just to switch the mass to the weight. Okay, and weight. It's okay. I think very early of this class, I just talk about what is weight. Weight is a mass. Weight is just a mass times the gravitational constant, right? Remember that? Remember that weight is just equal to your mass times the gravitational constant. Okay, so the center of weight is just equal to the center of gravity is just equal to center of weight. Okay, we just switch to your mass to weight. Okay, okay, center of mass, we are talking about mass. Okay, center of gravity, it just become the center of weight. Okay, and because in typical case, the gravitational constant is all the same. Okay, when I talk about very special situation, I think on the Earth, the gravitational constant, we can treat the gravitational constant is the same everywhere. So actually, yeah, center of mass is equal to center of gravity. Okay, okay, so okay, so this very trivial looks very trivial. Okay. And just what I say, center of mass, we care about mass. Okay, and then we just switch the mass to the weight. So here is total mass here, and we just switch to total weight. Okay, total mass, total weight. And here we integration with respect to a delta m. Okay, but in center of weight or center of gravity, we integration with respect to the delta w. Okay, and W, don't forget, W is equal to mass times the gravity. So delta W just equal to G times the delta M. Okay, because G is a constant everywhere. So delta W equal to G times delta M. Okay, so if we understand what's the center of weight, okay, what's next? Okay, okay, that's like what I say. Okay, okay, and then be careful. It's okay, and then M delta M. Okay, this is just the center of weight formula we show in last slide, and then we do a little bit further. Okay, M. Okay, if the M is a mass. Okay, mass is equal to density times the volume, right? Mass equal to density times the volume. So your delta weight is equal because we suppose our material has a uniform density and also in the same gravitational field. So your delta W equal to rho density times G times delta V. Right? And at the same time, your total weight is just equal to your density times the total volume times the gravitational constant, right? Okay, so since the density is a constant, G is a constant, so you can factor this out and cancel to each other. So you will get a centroid of the volume formula. Okay, you got the um it just change it to another name. It's just a position of your. It's also it's a position of a center of gravity or center of weight. Okay, in the center of weight or center of gravity, we use X bar, Y bar, and Z bar. Okay, and okay, we have the uniform density and uniform gravitational constant. So the center of weight just equals the center of the position of the center of weight just equal to X doing X and doing the integration with respect to the volume and divided by total volume. Here I should use the small volume first. Sorry. This should be small v. Okay, this is small v. Okay, and here should be a total volume of the system. Okay, yeah, this is small v. Okay, this small v. Sorry about this. This small v, the tiny volume element. Okay, not the whole v. Tiny volume element. Tiny volume element. Sorry. Tiny volume element. Tiny volume element. Okay. And so what's the position x? Okay, it is equal to x doing integration with a tiny volume and divided by total volume. And what position of y? The position of the y component of the position vector of the center of weight equal to the y doing the integration with respect to a tiny volume divided by total volume, and the z component of the position vector of center of weight is equal to z coordinate z doing the integration with respect to the delta v divided by total volume. And since you see the focus is switch from the weight to the volume. So we give a new name. It's called centroid of volume. Okay, the center of weight, we are focused on the weight. Okay, right now it all becomes a volume. So it will give a new name called centroid of volume. Okay, so let's see. Let's make a note here. It's called centroid of volume. Okay, all we focus now is become a volume. Okay, center of mass become mass, and then we go to the weight, and when doing the uniform density and uniform gravitational field, COG, is actually equal to the centroid of the volume. Okay. Okay, this is centroid of the volume. This is 3D case. So what's this related to the centroid of the area? Okay, this is 3D case, right? Because we just look at the centroid of formula for centroid of volume. It's for 3D. Okay, if your system is 2D, that's called centroid of area. This is 3D. Okay, so if you're 2D system, you'll become centroid of area. Okay, and centroid of volume, we care about the volume, total volume, and tiny volume. Okay, here I should change this to tiny volume. Okay. And for the centroid of area, it become 2D case. It can become when it becomes a 2D case, we are focused on the area. So A is a total area, and we integration with back to the tiny area dA. So in 2D system, the centroid of area in X, centroid, the position of centroid was centroid vector is the position vector of centroid, x component equal to the x doing the integration with the tiny area and divided by total area of A. And the y component of the position vector of centroid of area is the y doing the integration with respect to the tiny area and divided by total area. Okay, and so I think this will reach the conclusion. So what's the centroid of area? This is the final calculation, final formula for the centroid of area. Yeah, but I think this looks very abstract. I think you need some examples to solidify this concept. Actually, I will use this formula to calculate the centroid of right triangle. I will use the formula to calculate centroid of the right triangle, but I think that I will do it in the next video. And because this video is kind of too long, so so in the last part of this video, I just use the just introduce this use very simple this rectangular. What's the centroid of this rectangular? If the rectangular there's a side, one side is B, the other side is H. Okay, where is the centroid of this rectangular area? I think you don't need the calculation, right? Okay. Yeah, you can use this. You can use this formula. You can use this formula to demonstrate the position of the position of centroid of the rectangular shape. But I think you don't need to do that. This is very intuitive. Okay, I think the centroid of rectangular shape, the rectangular shape is here. Here is the coordinate is here. Origin is here. X coordinate and Y coordinate, and position of the centroid of rectangular area is B over 2 and H over B. Okay, I think you don't need to use the formal formula to calculate this, but you can try it by yourself if you want. Okay, but I think I will use this, just like I said, I will use this formula to calculate the centroid of right triangle. Okay, the centroid of triangle, because this is used a lot, so I need to demonstrate to convince you the centroid of the right triangle. Where is the centroid of the right triangle? Okay, so I'll just start a video here. This is just a conceptual video, so how to tell you where the centroid of area comes from. Okay, it all comes from the center of mass. Okay, here we start from discrete system of center of mass, and then we transform the formula to continuous system. And then in the continuous system formula, okay, we focus on the mass, right, center of mass, and then we switch from the mass to the weight. Okay, weight is mass times the gravitational constant. So the center of weight, we x bar, y bar, and z bar. Okay, you just switch from the and mass to the weight. Okay, and suppose we have uniform density and uniform gravitational constant, the center of weight will lead to the center of the body, centroid of volume. Okay, actually they are the same. Okay, and this is 3D case. So in 2D case, this formula will reduce to the centroid of the area, centroid of the area. Okay. Okay, so I will do the demonstration on triangle, center of right triangle in next video, and this I'll start video here. See you in next time. Okay, bye bye. It's kind of too long.